This is problem number 6 from section 3.1. In this problem they say, a carpenter is building a rectangular room with a fixed perimeter of 384 feet. What dimensions would yield the maximum area? What is the maximum area? First of all, maximum is asking you to find the vertex. Anytime they say maximum or minimum, remember vertex, if we would draw these out, the vertex is either the minimum on an upward facing parabola or it's the maximum on the downwards facing parabola. So this is a max, this is a min. Okay, so there's a very important distinction that you got to make in this problem. They say rectangular room, and they say the perimeter is 384. So what we need to do is we need to draw this room first. Let's draw the room. Doesn't matter how you label it. We'll say these are the lengths. We don't know those. Those are the widths. But we do know the perimeter, and the perimeter is going to be 384 equals, perimeter, we just add the outsides, right? So that's 2 L's plus 2 W's, right? L and L, W and W. This is the perimeter equation. We can go ahead and write that right here. Perimeter. Okay. Now, we're looking to maximize area. Perimeter is not an area. What is the area of this rectangle? Well, we can write that here. We'll label this the area. And we know the area is going to equal length times width, L times W. Now you'll notice in both of these equations we have two different variables, right? And technically this one we have 3, A, L, and W. This one we just have 2. We want to combine these two equations together because we're trying to maximize the area based on this perimeter. So we have to combine this equation with this equation here, with the area equation, perimeter with the area equation. In order to do that, let's take this equation, 2L plus 2W, solve it for either L or W, and then plug it into this equation. Okay, let's go ahead and say that L is the variable we're going to solve for. Subtract 2W over, you get 384 minus 2W equals 2L. Divide by 2. 384 divided by 2, 192. So we get 192 minus W equals L. Take L equals 192 minus W. Take 192 minus W, plug it in for L, and we'll get A equals 192 minus W times W. We'll distribute in here and we get A equals 192W minus W squared. Rearrange this and we'll get A equals negative W squared plus 192W. Okay. Now, there's an important thing that you need to understand now. This is a quadratic. If I find the vertex of this quadratic, so vertex here, the x value is the width. The y value is the area. So if I want to maximize the area, all I got to do is find the vertex and look at the y value. And that'll be my maximum area. So let's go to our vertex formula, which is right here. And let's go ahead and use this negative b over 2a to solve this problem. So we're going to start with negative 192 over 2 times negative 1. That gives you negative 192 over negative 2, which is 192 divided by 2 is 96. So the width here is 96. So we're going to go ahead and write that as our W value there, which means our area is a function with 96 plugged in for the width. Oop, better slide that up. Okay. So what's f of 96? F of 96 equals, if I plug in 96 into the function, which I have this right here, that gives you negative 96 squared plus 192 times 96. When you plug that in, 96 squared times negative 1. Then I just add in 192 times 96, and I get 9,216. And they're talking about feet, so that's feet squared because that's the area. So this is the maximum area that you can have for a rectangular room with a fixed perimeter of 384. Right? Rectangular room, fixed perimeter, 384. Do they ask? Oh, they do ask for the dimensions. I missed that part. So it says, what dimensions? Well, I have the width, right? So I'm going to write all this up here. The width is 96. So what's the, we need to find the length. We know the area, which is 9,216 feet squared. Well, if the width is 96 feet, what's the length? Well, we can come back to this equation that we have. I have it covered up. But this equation right here, it says 192 minus the W equals L. So if I go ahead and say 192 minus the width, which is 96, I actually get 96 feet for the length too. So this is our width, length, and area. And these are the dimensions that will yield the maximum area. Now for a rectangle, you're going to notice the maximum area for any rectangle is a square. That's why the width and the length are the same. So, I mean, anytime you get a problem like this, you know that the maximum area is going to be a square.